All right, well, we can go ahead and kick off the discussion period then. So, this discussion period will be a little bit different than the panel discussion we had before. So this is kind of our time to just come together and talk about really just everything we've talked about today. First off, are there any landing sites or scientific investigations that we maybe just didn't discuss today that anybody would like to bring up, just to make sure it's out there for consideration? We can pull up the Miro board here in a little bit, look at some of the things that have been put in there. And then, if there's any other discussion about, the different, types of investigations we can do given, increasing amounts of capabilities. Kind of now is just, again, the time to, in a sense, brainstorm together as a community. I know we've had some discussion on, campaign science. We've talked about a lot. We could talk about that again if people would like to. Just to kind of get a better handle on, all right, what are the science investigations that people are thinking about, and then what can we really do maybe now with the capabilities we have, which at this point are pretty much static landers and mobility, and then, as we start to increase capabilities, what are the things we can really start doing. I don't have like any question ready. If anybody wants to chime in, we'll kind of pause for a minute. Otherwise, we'll pull up the Miro board and start looking at it. Oh, and thanks to everybody who is using the Miro board. I see a lot of action in there right now, so that's really great, really helpful for us. All right, I'm sharing this. Hopefully nobody gets too dizzy or anything with the action going on. And, please continue working in here. So I've seen a couple neat things crop up. I also like that people have been putting in, so I see here under static lander, just instruments. We didn't really talk about specific instruments today. It wasn't, the primary focus, but, there are different types of instruments that, we could just try to throw on, as many landers as possible that can answer science investigations at a variety of sites. I don't know, does anybody want to speak to some of the kinds of instruments that are on here, seismometers, heat flow probes, etc.? I cannot see the chat at the moment, so I might need some help with that.
So there is a question in the chat, but it's not about instruments. So
that's fine. We can answer the question and then come back to instruments.
All right. So Barbara Cohen has a question. What is the limitation on mass for current CLPS lander calls? Seems like most providers can fly significantly more mass than SEO allows in its calls or payloads.
Brad, are you on? Do you want to take this? If not, I can try to tackle it.
I am on. Could you repeat the question again? I'm sorry.
Yeah, it's just what's the limitation on mass for current CLPS lander calls? It was pointed out that it seems like most providers can fly more mass than what we allow for in our proposals.
Sure. There are several classifications of landers overall. There are several small landers that can, take up to 30, 40 kilograms. A lot of the ones that we've solicited for thus far are a little bit more in the 100 to 120 kilogram class. But then, of course, Griffin from Astrobotic is taking Viper, which is, 500 kilogram class, and Maston, I think, also has a mass range in the 350 kilograms. So really, there are a range of landers available to match the science that we need. Again, it comes down to available resources to solicit for them.
So, Brad, it's Barbara. Can I just follow up on that?
Please.
I feel like a lot of the things that we're talking about here, we're talking about survive the night and mobility and adding an arm and stuff, and all of those things are increasing capabilities. But there's already a capability. The capability is mass. There's a capability we're not exploiting, right? So I guess that's where my question is coming from is, if it comes down to we don't even have enough resources to use available mass on current designs, how are we going to get the resources to do any of these other things? Or conversely, what is the plan to increase the resources available to get some of these other things, and can we start with mass?
Yes and no. So I agree with everything you said. My additions to that would be, as we start getting more flights under our belt and there we get some experience, the expectation for these initial landers, the static landers, whatnot, is to go down in overall cost. Um, and that allows us to start soliciting for other capabilities. So we, without getting too much into the nitty gritty of our budgets, we have talked about every other year a significant or larger eclipse delivery that would take advantage of those. But we're still trying to figure out how that budget works out in the long run as we're kind of running into the trials and tribulations associated with some of these early deliveries. So there is a plan in the long run to have those enhanced capabilities, particularly some of the ones that are a little bit more advanced in and will cost a little bit more as you've been talking about. But I'm sorry, there was a second part of your question that I think I was going to address, and I completely forgot what it was.
Yeah, that's okay, Brad. I guess the crux of your answer is that our expectation is that the cost of the landers is going to go down. The cost to NASA of these Eclipse deliveries is going to go down, and that'll enable us to use more capability, whether it's an arm or mobility or sample return or mass. Is that
Right. That's largely correct. Yes. So like kind of the baseline lander, so to speak, the cost for that will go down. And so as we add arms or sort of the night extra battery mass, et cetera, onto that, then we're hoping that the two balance out or that one doesn't completely outweigh the other. I just remembered the other thing that I wanted to say was that, yes, a lot of these vendors do have excess mass available on board their landers above and beyond what NASA asks for. The problem there is that for us, mass, of course, costs money. And so, the RFI that was sent out on Prism a year and a half ago now, or however long ago, really the data came back to showcase that with pretty large error bars that we were looking at about $1 million per kilogram for payload mass. And so even though there's excess mass on board there, we don't really have the instrument budget to take advantage of that mass. So again, we're a little bit budget limited on taking advantage of that mass. And the other thing I would like to say is we also we NASA don't want to take up all that spare mass capacity on landers because as we've mentioned, it really is, we are trying to set up this lunar economy. And if we take up all the mass all the time, then it's a NASA sponsored program as opposed to a worldwide sponsored program. So we still want to leave room for the vendors to go out and solicit for other payloads from external to NASA entities that will really kind of help, feed that overall lunar economy. I'm hearing
Well,
crickets
thank
in
you for
response.
that,
So
Barb. That was a good discussion for starting this off for sure.
So I was going to toss a question back out to the group. There are a few more in the chat, but I think we'll kind of bounce around a little bit. So we've talked a lot today about, specific sites that can be accessed, and some of them need static landing, and some of them potentially could have, very good science with just a static lander. But then if you add mobility or survive the night or an arm or something, right, you could get an enhanced science. And we've also had this conversation about campaign science, potentially using multiple CLPS landers in a region to, get sort of a picture that's greater than any single lander. And I was kind of wondering what people thought, if there's sort of a community consensus of, if we have a site that has good science with a static lander, but perhaps better science with enhanced capabilities, are people good going to it with, a static lander and then somewhere else later on? Campaign science is a great thing, but might not be the best option, or do we want to wait until we can get those enhanced abilities? If that makes sense. I don't know if anybody had thoughts on that. We've been talking a little bit about road mapping and prioritizing, how people feel about different sites. Or did I just confuse everybody?
Now, are you just to make sure you're asking if you had the option of waiting until you had a really capable rover versus campaign science, essentially, at a particular site, maybe?
Or just going now and getting some science with the understanding that maybe campaign science doesn't make sense for that site, or you might not get that other capability. The interest of prioritizing or picking
Yeah,
sites for.
I'd be curious to hear from maybe somebody today who's spoken to a campaign science idea of what they might think about that. I'm just trying to see who's still on.
Yeah, this is Tim. So maybe this is my naturally pessimistic nature, but I think I would say kind of follow the old adage that a bird in the hand is better than two in the bush, right? And so if I had a guaranteed static lander, I would figure out the best science I could do with that and propose that, and keep my fingers crossed, but not count on something better coming along with it, right? So I'd rather get the kind of science we can do with within the constraints that we have, and be realistic about that, than kind of keep fingers crossed for something happening down the line. That's just me.
Yeah, that absolutely makes sense, Tim. That's kind of where I feel like that too. Some in situ science is better than no in situ science, but just curious if everybody else felt that way too.
Well, and I think.
Go ahead, Noah.
All right. Well, I'll just echo what Tim said, and you get what you get, and you don't get upset. And so, if we go to a place, let's say you send a static lander to Aristarchus with limited capabilities, as long as that doesn't preclude going back with a rover or doing something else, that's fine. Because as soon as you understand one thing, you go with a modest set of experiments, you learn something that will inform what you do, that will make the subsequent mission that much better. And so I think I'm all for sending simple static landers ahead of more robust missions, because then that robust mission that comes down the line, and Tim, as a Red Sox fan, your skepticism is understood, but it shouldn't remove the possibility of, hey, let's go back to Aristarchus, because now we know more, and we'll make that subsequent mission that much better. And so as long as we can be assured that as soon as you land in Birkeland on the far side, that doesn't, let's go back to the check in the box analogy, that doesn't check the box for SPA, we're done, we walk away. No. Now we want more. And so as long as we know that we're not going to be, that will be held against us, that we send a simple static lander to a particular location. And as I advocated before, going back to a lander is really important, especially if a few years have elapsed, to learn what's happened to that lander. It's a natural experiment.
Could I add another dimension to this discussion, because people haven't come back to samples? One of the advantages for sites away from the poles is we can obtain samples and don't really have to worry about protecting them, and they're not going to melt, and et cetera, et cetera. And I really think and I've got a couple ideas myself, but I'm sure other people can expand this, that a simple static lander that grabs 2 kilograms of sample, we could identify 10 sites. If we had that simple capability, static lander, 2 kilograms of samples, I bet we would have a whole program that would take off for the next millennium. No, well, maybe 50 years.
Carly, this is Barbara. Can I just follow up on what you just said? Like, there's a part of me that doesn't disagree with you, but then there's also a part of me that as we're working on human mission return to the moon, there's a wonderful CAPTEM document that says we need 200 kilograms of sample
Oh,
return. Right. So how do we square that circle? Do we need 2 kilograms? Is that going to give us everything we need? Then why aren't we asking for 2 kilograms from crew return?
I think that's the major distinction, Barb, that for some sites, and we know, and Brad Jolliffe and et al. Has done a lot of work on this, in the 2 kilograms of good regolith, there are so many little nuggets that you can piece together a grand story. Now, that doesn't mean 4 kilograms is going to give you twice as much data, but 2 kilograms will give you enough to really look at the character, and all those little nuggets are going to be giving you a basic story for that site. Now, that does not address the kinds of things I know that you'd like to do, which is getting more pristine samples, getting good rocks that are 2 kilograms themselves. So it's a different category, but as long as CLPS can have pinpoint landing and get 2 kilograms of sample, there's a wealth of information that can be obtained about the character of the moon. So we're not in disagreement.
This is Dean Epler. I wanted to just throw some 2 cents into some of the things that were discussed just a little bit before. I've been around the business a while, and one of the things I've watched is missions start to become enormous because everybody's afraid they're never going to go back there again. So pretty soon we have a $100 million mission. It's big, heavy lander, all that stuff. And sometimes they get canceled because of that. I think one of the philosophies about CLPS is simple and cheap and not as many things on the lander. And if we have to go back to a place again because we couldn't get everything on the ground the first time, but found something really interesting, I don't think that's a problem. I'd hate to see bracket creep and requirements creep sneak into CLPS until we're getting these enormous missions again. And then the whole purpose of the CLPS program disappears.
I think it makes sense to think in terms of kind of a cascade. It's like, what are we doing now versus what are we moving towards? And if we think in terms of like a large number of separate missions, that some of which might be small and some might be large, but we're sort of like doing the initial missions that begin the cascade that follows later, and just sort of design around that idea, like a static lander maybe might make a lot of sense, and then have another lander in the same location that has a rover on it that can do maybe a little more than what the static lander alone was able to do. You think in terms of a progression of missions, so there's a whole campaign running in parallel with other campaigns and whole programs for given regions that are running in parallel with other regions, that it's not just like a single dart, it's like an entire game of lots of darts going all over the moon in lots of locations, according to where somebody thinks a particular location is interesting. And then with maybe a few small missions, we prove that an area really is interesting, or maybe a given area is not quite as interesting as another, and then we can sort of shift priorities around. And then once we understand the priorities and we're getting the initial levels of data, that there's sort of this understanding that emerges out of all of that, that says, these are the important locations, let's send the larger missions there, and then start getting the big results. And when it comes to sample returns, try to send maybe some small samples at first, but once an area becomes especially interesting, we know there's maybe a whole variety of samples that we want to obtain from that location, then we can have the larger samples returned, and then have a complete infrastructure that emerges out of that kind of cascade strategy, where the moon is a destination where there's all kinds of commercial activity going back and forth between the Earth and the moon.
Agreed.
Yeah, these are all really great points. So everybody. Dan, I see your camera's on. Did you have something to add, or are you just being social?
Yeah, so it was going back a few minutes to some of Carly and Barbara's points about, I think a good strategy for a clip sample return mission would be to kind of simplify the collection process as much as possible. So I'm always tending on the side of trying to reduce in situ characterization as much as possible in order to return as much sample as you can for the least amount of money. I think in the end, getting more sample back is more valuable than any type of in situ analysis you can do on the surface. And I think something that is enabling of that is our remote sensing analyses are getting better and better. So especially as we are able to get like Trailblazer data with higher resolution spectral characterization of surface materials. Yeah, I think we're getting to the point where we can kind of grab a highly targeted scoop from an area on the surface without having to do too much kind of picking and choosing while we're there. So that's the type of thing that could help reduce the complexity of any kind of surface sample return operation. The biggest thing is then, yeah, I guess getting it back to Earth. But reducing kind of down mass could be done through kind of reducing the amount of actual characterization we're doing on the surface.
Ryan, were you asking about how do you figure out the mass?
It wasn't me who asked. Somebody did.
I was just going to add to what Dan just said, that really the mass is determined by what questions you're trying to answer. And, you know, in the case of a regolith sample, if you're, say you're trying to get samples back for geochronology, you have to think about the percentage of materials that are going to be there that might be potentially, datable for what you're trying to determine. And so you can kind of back it out from there, what you need, what sample mass you need, what size of rock fragments you might need. And that kind of dictates, at least that's the way we did do this for New Frontiers proposals. And the conclusion we came up to was 2 kilograms is a great sample, especially if you can do some high grading by sieving it.
Well, these are all really good discussions. Just trying to keep an eye on the chat here, and I've got like 10 windows open. There goes. Let's see. I got to scroll way back. Where is the first thing that came in? I know Amy and Brad have had a little chatter back and forth that you guys can take a look at to summarize. I know Amy had asked that we said that CLPS can revisit a site if the community prioritizes it, and so what would be the best path for the community to get that information out there? Sorry, it's jumping, so I'm trying to read it as it jumps.
Can I raise another point about sample return?
Oh yeah, go ahead.
Marshall Eubanks here. Yeah, so we're going to have, I would hope, Artemis landing at the South Pole, and so it's actually technically a good deal easier to get samples to an Artemis base camp at the South Pole than it is all the way back to Earth. If you're going to go all the way back to Earth, you have to have an ascent vehicle, you have to have a return vehicle, you have to have tracking for all of that, so on and so forth. And so I wonder if that's not possibly an intermediate point where you could bring samples to the South Pole and then bring them back, and whether you could, even pay companies to bring samples to the South Pole and bring them back. Even if you could start locally, you could start, well, we're going to be down in Shackleton Crater. If you have a rover that brings it up to wherever the base camp is, we'll take that sample. Say, now, of course, you might want to have that in the thermos or something, but you see the point there is that you could start much simpler. Sample return is not easy because you got like these hard, you can do lunar orbit rendezvous. Well, that's not simple. It's complicated. Are you going to do direct descent? Then you have to have a good return vehicle, so on and so forth. But just to say, well, here's this rover and it's going to go over to Artemis Base Camp, that sounds a lot simpler to me. And maybe the astronauts bring it all back to Earth. Maybe they don't. That's another decision that, you know, that could be made, you know, by them, not by us.
Isn't that only applicable for polar samples?
Well, I mean, some of us have been thinking a good deal about lunar mobility. And, you know.
Yeah, Marshall, I think that's really interesting. I've not heard that before, but you're right. If you had to land something on a CLPS lander and it had to ballistic hop to a pole as opposed to all the way back to Earth, you would assume that was less mass and therefore cheaper.
Well, yeah, I mean, if you say, I want to be able to move 100 kilometers ballistically or on a rover, either way, then the question becomes, can I extend that? And the answer is typically yes. It's a matter of, you know, planning and so on. And so I don't, again, you might start with a short hop, 50 or 100 kilometers, but I think, I mean, we're trying to develop a lunar economy here. That's part of what CLPS is, and developing a lunar economy is going to require moving stuff around. And so that seems like something else that CLPS should be developing. Start simple. Don't try and do it on the first mission, but it seems like that's something that could dovetail very well with what Artemis is doing.
Yes, but as I put in the chat, that's just kicking a can down the road. Artemis return, sample return is very limited. They haven't even dealt with how you would do a cryo sample return system, and that's not going to be heavy or power limited. So, you know, you could do that, but you may find your samples are sitting around the South Pole for a long time before Artemis can bring them back. And that may not be as hard as doing it for CLPS. I'm not saying that that isn't a bad idea, but Artemis is not the be all and end all response to this.
No, and again, I think there needs to be some discussion about, well, you know, what can you do with different kinds of samples? You know, a little 1 gram sample is useful, or, you know, is a kilogram sample 1,000 times more useful, and so on. But I was at a presentation where they were talking about bringing each Artemis mission, bringing back Apollo levels, that is to say, several hundred kilograms of samples. So they could include a 2 kilogram sample if they wanted to.
Well, I've been in the middle of that battle for over 15 years, and I tried to get that, and I've been constantly slammed and found that the 100 kilograms was turning into 10 kilograms, and that includes the sample return containers. So CLPS hasn't embraced, Artemis has not embraced Apollo level sample return requirements ever. And I don't see them doing that in the future or anytime soon, at least till we have a workable vehicle. Now, having said that, I will point out that Apollo did not have any requirement for sample return, and we got our sample returns back from the margin that ended up being built into the LEM because of the decisions that the managers made in terms of, you know, Delta V reserve. So saying that Artemis doesn't have it on the requirements doesn't mean it won't happen, but until you understand what your vehicle can do, which means you have to build it and fly it a few times, you're not necessarily knowing what you're going to get back. And we didn't get more than 100 kilograms back until after Apollo 15.
And I don't think we want to wait 20 years to get samples back.
Roger that.
All right, thank you guys for that great input on samples. I'm actually going to kind of steer our ship in a little bit of a different direction for a little bit, just because there's been some stuff in the chat that I wanted to make sure that we brought up. So there again, oh, I just lost it. Got to pull it up again. There we go. So yeah, I know Amy had some questions about, oh goodness, I've lost it again. Yeah, so the best path for community to demonstrate if we want to revisit a site, should we have workshops, a white paper? And Brad had a good response. The first line of evidence obviously is workshop. I'll just read what you said, Brad, and you can jump in if you want to add anything. That, you know, as we manifest payloads for a specific site, if the community feels that
it's okay. I can eat during my next telecon, and I'm still
yeah,
like
Bethany, you have a hot
high, which is why I'm having my lunch now instead of like an hour ago.
Bethany,
We got an open mic.
I think we might have gotten it. Okay. Anyway, yeah, so as Brad mentioned in the chat, as we manifest payloads for a specific site, if you as a community feel there's gaps existing in the data or any keeps jumping, or any enhancement of the already planned data sets, we can put that back into, he said the hopper, back into consideration for other solicitations. And that, yeah, we should have workshops or special sessions kind of on this kind of topic every 1 to 2 years to just keep continually refining the strategy. And there was also some related kind of questions and comments about, roadmap plans, kind of the things we've discussed today of, what does, what is our strategy moving forward, essentially. So what is our plan for that and who should lead it? We've kind of chatted on the side a little bit that, yeah, we agree with some of the comments that have been made that the league is in a good place to kind of head this up. I'm kind of thinking maybe, even update the league roadmap and add in some CLPS science, just add in some stuff like we've talked about today that we can then use as input for kind of driving our plans moving forward. And these are discussions we can have a little more outside of this workshop with folks in league to see what that looks like. But yeah, obviously we value your input and want to make sure that the community is heard as we move forward in strategizing how we plan our CLPS science. What else is in here? So there was a question. Oh goodness, I gotta find it again. I think it was Heather. You had a question about GPR. I don't know if you want to unmute and ask your question, just because I'm having trouble finding the actual question.
I was just wondering if in several of the talks people mentioned GPR, and I was curious if there was already a company that's developed a GPR that's space qualified, or if there is, if you're looking for the CLPS providers to develop that. And then I guess the other question I had while I'm unmuted was like there was some discussion about having like a cutoff between whether a mission should be CLPS or New Frontiers or whatever the other one was, and who will determine that or provide that criteria, which is not related to the GPR, but just sort of a separate thought. And then lastly, I just wanted to mention, on the sample return side of things, I didn't hear, maybe I missed it, but the possibility to not do direct return and go through Gateway, it would probably be easier to dock with Gateway and then transfer samples to the crew return vehicle in terms of just total capability. So that might be another architecture option for sample return.
Great. Yeah, I don't do GPR, so if anybody wants to speak to that, I know there's been a couple comments in the chat about some international agencies that have GPRs. I know with like CLPS or specifically PRISM, we don't, telling a vendor, a CLPS vendor that we need a GPR. That's not really part of what we do. We put requirements on them for other things, capabilities and whatever it is that our payloads need. In this case, we're going to ask them for mobility for PRISM 2, or maybe would ask them for robotic arms, things like that. But we don't ask them necessarily for instruments like that. That is something that we would leave up to the PRISM teams to propose to include as part of their suite if they had one ready. That's probably the best answer I can give you about the GPR, just because that's about the extent of my knowledge of GPR. But again, if anyone else wants to chime in.
I can say a little bit about the GPR side of it. I mean, yeah, I don't know of any other than the one that is now on Perseverance, where we do at least have one flight is being proven. At least from the early results I've seen, it seems to be producing good results. And the ones that have been, of course, flown by the Chinese. But I think it's a capability that certainly the technology is there. The knowledge to process the data is mature. So I don't think it would be a big challenge for to put that instrument to put a multi-frequency GPR together for a lunar mission. I don't know whether that helps or not, but
Well, JPL was testing one for Mars. I don't know if they had that ready to go or not, but they were definitely testing one for Mars.
oh, they were. Interesting.
They were also testing it for lunar applications.
Oh, that's good to know.
Just to add on to what Ryan was saying, a quick note on philosophy from a CLPS perspective is that we're not asking the CLPS providers to do science. We don't want them to do science. That's the role of the community. If there are specific requirements or accommodations that are necessary for taking samples, for example, we just need to spell that out very specifically, such as take an image of the lunar surface. So what does that mean? I mean, there are different interpretations and ways of doing that. And so when we write that out, it's kind of hard to codify or to specify that in the RF in the request for proposals from the vendors, because they have a lot of different ways they can accomplish different things. So in general, we don't ask them to do science. We only ask them to accommodate our science, if that makes sense.
So Brad, can I follow up on that?
Please.
So then, I don't envy you guys writing those contracts. One, that sounds hard to make sure everything gets done. But is there a way, and this is one of, I think, one of the goals for this workshop a little bit. Is there a way that we as a community can provide you with better information about those things that might need to be included in a request for proposal, so that we can ensure that our science gets done the way that we envision?
Yes and no. I would say that we'll always take information and try to weave it in as best as possible. As part of the PRISM solicitations, we've included examples of Appendix A, which are the requirements and accommodations that are required from the vendors that are specific to the payloads that NASA wants to have flown. And so you can get an example of kind of the things that go into those appendix examples, the level of detail, and above and beyond that, we sometimes ask for specific spacecraft data that will enhance or complement the data coming back from the instruments as well. So that's a complicated question, and the answer is yes, question mark, but I'm not sure what it looks like at the moment.
All right, that's fair. I was just trying to make your job easier.
Yeah, no, and I love you for it. We'll take as much easy buttons as possible.
Lost track of the chat, so.
Yeah, there's a lot going on. We'll just do our best. I know there's a lot of chat on samples, which we've kind of spent some time talking about, so I'm not going to really read all of these. There was a question about maybe a future league or a lunar surface workshop that addresses sample return priorities, possibilities, and commercial on-ramps. So that's a good comment that can be considered by any one of those groups. I had seen something in the Miro board. I don't necessarily need to share the screen, but I'll find it again real quick. Again, thanks to everybody who's using this. We got some good stuff coming up with some various types of science investigations. I did notice, a new capability added for manipulators. Actually, that's what I was going to do. I will share it real quick. Tab up here and do the thing Angela taught me where I can hide all of the cursors so nobody gets seasick. Yeah, just curious if anyone throughout the course of the day or just right now in real time has thought of any other types of capabilities beyond the ones that are just listed here that should be added, that are things that we could consider, as we try to determine what capabilities vendors have now or may have in the near term. I know one that I don't think is listed here that we've heard come up at some point was like electromagnetic cleanliness. Some instruments may need clean environments, so that's a capability we could add. Yeah, just curious if there are any other kinds of capabilities that folks have thought of throughout the course of the day. And that's fine if not. I do think we've covered quite a few of them here. There's maybe another.
Hey, Ryan.
I don't know if it's,
Someone
yeah,
asked in the chat if we're counting cold storage as part of sample return. So perhaps cold storage would actually be valuable to list as an additional capability.
Just going to add it here. I'm not going to add anything else. If folks want to throw some stickies on there with thoughts about stuff like that, we'll keep it separate from sample return for now. Let's see. So there's one up here, another SEO clips. Oops. I may need to rely again on Brad here a little bit. Have SEO or clips thought about providing mission management, which would allow universities to be more competitive? And there's a question: do PRISM calls come from usual suspects? How can we get more institutions and individuals involved? I'm thinking real time about this. Brad, do you want to hit the mission management part, and I can think a little bit about the PRISM one?
I guess I'm not quite following that. So right now as it stands, we run all of our PRISM selections from an instrument management perspective through the PMPO, the Planetary Mission Program Office out of Marshall, and they do a lot of the management of the instruments for NASA. We do a lot of things that I think in general allow for better participation from universities, particularly smaller universities that may not normally play the game as large a field as discovering new frontiers, and those come down in the form of operating things on 7120.8, which is more technology development, again higher risk posture, but we do offer cooperative agreements, which are easier for smaller institutions to absorb and work with, as opposed to working with larger government contracts. And so in general, and coming back to that risk posture, it really does open the door to those smaller organizations. So I'm not sure I hit on what that question was specific to, but I'm hoping that it at least lets you know that the types of institutions which can be competitive are much broader than you might see for a larger mission.
Yeah, no, I agree with Brad. I don't know if I have a lot to add that might hit it, this question, this comment, but yeah, how can we get more institutions and individuals involved? I mean, to some degree, it's kind of up to, in terms of getting individuals involved, sometimes it's up to proposal teams to really be as inclusive as they can. And yeah, we want proposals from a variety of institutions, and we want this to be a competitive process. So I don't know if I really have, I mean, and do they come from the usual suspects? Well, we've had, two PRISM calls now, so it's kind of hard to answer that. But, we do get a good variety of proposals in. So we hope that it stays that way, and that, yeah, teams continue to, oh, go ahead. Yep.
Oh, I'm sorry. Yeah, sorry. I was just going to add in that, I mean, some of the things that we also do provide are payload integration managers through the CLPS office that help, that work with the hardware and making sure it gets integrated onto the vendor's spacecraft appropriately. We also have project scientists that kind of oversee the overall process from a science perspective to make sure that the science is well integrated and working on ConOps and whatnot once they're on the surface. And then there are within PMPO, there are specific mission managers that look at the overall manifest and again, working with the vendors and the CLPS office and the PIs in order to make sure that everything is working as intended. So there are a lot of things that we do to ensure that your science and your instruments are being well taken care of.
Yeah, thank you, Brad. Just because it's in the corner of my screen anyway, I know we briefly started talking about this sticky here with, just different, these instruments, flying them, everywhere. And yeah, I mean, we've talked, we've said in, the PRISM solicitations that, at some point we plan to solicit for site agnostic instruments or standalone instruments. So yeah, I mean, these are kinds of things that we would love to see proposals for, these types of instruments that we can just have ready to fly, fly anywhere and take a lot of great measurements for us. So yep, definitely keep those kinds of things in mind for when those calls come out. And real quick to see if there's anything else that we want to get on in here. What time is it? Minutes left. Yeah, I mean, again, I'm not going to go through all these sticky notes. You guys are working on this in real time, and thank you for that. And yeah, and again, this will be open for probably a week or so after the session. So feel free to come in here if you're like, oh man, I wish I thought of this thing to say, and go ahead and come in here and add it. We'll keep it active for a little while. See if there's anything else that's come in the chat here. Yep, James had a good comment on SEO keeping track of selections down the line. Yep, definitely can do that. Anyone else have any questions or comments about anything, landing site, science objectives, strategy that you want to bring up at this time?
I just threw in a note about, again, I think Clive brought it up this morning about, and again, I'm not sure that there's anyone in the group who can really address this directly, but just the idea of what it's going to take to make these lander rover, especially a lander rover combination, and what I'm interested in, able to survive multiple lunar nights. I mean, is it a technological challenge that's going to double the cost of the missions, or is it just battery mass issues, or no one knows?
Hold on.
Good question.
I'm more chattering, Glenn. We're looking at the possibility of hibernating the spacecraft. We're looking at the cells. We've already found out that certain lithium-ion cells can tolerate the cold and be resurrected when they're warmed back up. But you need special electronics that can operate at lunar dawn temperatures to restore the system, and we think we could do that. But our question is to the community is, are all your instruments going to die overnight? Because I think the main spacecraft, the power system anyway, should be able to recover.
But you would put it in a hibernation mode and let the lander / rover get cold?
Yes.
Okay.
Most instruments have a safe mode, which requires a little bit of power. So getting an estimation of how much of that is needed through the night would be worth doing.
So what was the initial question? Something about, is it just a matter of mass and batteries?
Yeah, I guess I'm naive. I don't know what the in detail what the technological issues are. I mean, outside of having an RTG or something, which I think is not gonna happen for CLPS. What are these challenges that are really keeping us from saying, yeah, we can get through multiple lunar nights?
I think the number one challenge is FUD. right? We've not done it, and there's a level of engineering we've not needed to do. There are novel technologies, both from low conductance materials, new novel approaches to thermal isolation. There are approaches like Rich Effering mentioned with hibernation technologies, but I think we don't design the same truck to go to the equator that we do to go to the South Pole, right? So learning how to design our systems to go to lunar destinations and have them survive the night is something we've got to just learn how to do and operate in. So I think we understand some of that, but I think there's a significant amount of uncertainty. And right now we're asking folks to sign up and say that they can do it. And I don't know that we've just studied it enough, but we are actively working on technologies to do that. And thank you to Brad Blair for plugging our focus group in LSIC, where we look specifically at extreme environments.
Several years ago, before like a one-day meeting before the league meeting, it was when we were at USRA headquarters, they had a Survive the Night session.
Oh, right.
And I was actually kind of shocked in that I thought this was going to be like the holy grail, the impossible thing to do. And quite a few of the people, the manufacturers, the industry guys at this meeting were kind of like, no, we could do that anytime. All you need to do is tell us to do it. So apparently this is not as big a problem to some people as it is to people like me that don't know how all this stuff works.
If somebody tells you it's easy, they're being disingenuous.
Perhaps, but
it's not impossible.
Yeah, they had technology that they felt, that they tested to those temperatures and those durations. I mean, the Lunicod did it quite simply with, having everything inside a thermal enclosure that had closed up like a tortoise on a lunar night, and there was power in it, kept it warm, and when the sun came up, it opened the lid and off it went. And they operated for several lunar days. Again, the other thing is, are you talking just about hibernating at night, or you're talking about operating at night as well? Because those are two different beasts.
Yeah.
Let me answer that one. We hibernate at night. Well, basically, you have to tolerate the cold. It's going to be cold. It's right at lunar dawn, so that's what the temperature we're looking at. And basically, the electronics should be able to tolerate that and then operate that. And it looks like good evidence that that can be done. And a lot of that comes from the quantum computer arena, where they're taking these electronics down to these temperatures.
Yeah, it's a good point about operating, because let's say I'm thinking about, and even Mark Panning and the FSS, and again, I'm proposing something similar for landing at a young fault cluster, is that to detect these shallow moonquakes, you're probably going to be lucky if you have 4 to 5 of those over a year, based on what we saw with the Apollo seismic network. So the idea that you could actually operate a seismometer or 2 seismometers at night or through the night is kind of an important part of that, I guess. It's not. You're right. It's not just the surviving. The rover, you'd like, again, to be able to, you could shut that down and figure out how to survive, so you're operating only, again, under optimum conditions. It would be nice for the lander to have the ability to at least operate some instruments through the night, even if much of the craft or the lander was in minimum energy mode.
The Intuitive Machines lander is talking about going into a polar crater. One of the things that makes that a complex issue is whether or not there's mercury in it. You don't want to make landing pads out of aluminum, because mercury will amalgamate it and dissolve it. There's a lot of other metals that's a problem with as well. So watch out for chemistry. It's not just the cold.
All right, thank you guys for that discussion. I know there's some chat going on about other technologies and things, but we're getting pretty close to the end of our time here. So rather than try to dive into another discussion, I think we'll go ahead and thank everyone again for coming today and the really great discussion. I do want to mention before we go, But if you just can't get enough of these LSSWs, you're in luck. We have more. So our next one is coming up. Hold on, let me get the date pulled up here. It's January. I have the slide. I'm not going to show it, but it is January 26th and 27th is our next session. This will be on inclusive lunar exploration. So looking at how we can advance inclusion and diversity in the lunar science and exploration community, and what does it mean to explore the moon responsibly, ethically, and inclusively. So registration is open on the LSSW website. Abstract submission is closed, but you're free to contact the co-chairs, Kristen Bennett and Parvati, with any additional suggestions you might have for discussion topics. So be sure to check that out, and then stay tuned for the sessions coming up in the spring. And again, the Miro board will remain open for about a week or so. Feel free to go in there and keep doing input. Email us if you have any final parting thoughts. And again, many thanks to our documentarians, Emily Cully and Lauren Jazwiak, who've taken notes for us all day today, hung in there, and helped capture this really great discussion. And thanks again to my co-chairs, Angela, Sarah, and Amanda. And enjoy the rest of your evening, everyone.